In this tutorial, I'm going to show you how to get a local language model running on your computer. So the first thing you're going to need to do is you're going to need to download your chosen language model. You don't want to download anything particularly big because it's not going to run particularly well on your GPU or whatever system you're using if it is a huge language model, technically a large language model. So you're going to want to choose something small. I like Small Llama. Just choose the smallest or second smallest version of that. You can find that on Hugging Face. Just download all the files and put them in a directory, and the directory above that include just have your query.py or whatever code you're using to run this. So first thing we're going to do is we've got to build a querying piece of code. We're just going to use some simple Python for this, and this is just so we can check what the language model outputs and we can see if our training works. And well, just to utilize the model at all. We're going to need a few modules to get this working, and I'll list them here. You just pip install or conda install, whatever you want to use. Transformers, torch, protobuf, sentence piece, data sets, and accelerate, and it has to be at least 0.26. You also need to know that you will need to use Python 3.7 to Python 3.10 because otherwise you will not be able to use Torch properly. So what you need to do once you've got all that installed is you need to load it. We need to get the model. And the tokenizer, and we also need to get Torch. So next thing we need to do is we need to actually load the model. So I'm going to print loading, and model equals, it's just this part of the module here. And we get from pre-trained, and we need to use the directory that the model is in. So we're going to use to get the tokenizer and the model. And then we need to set up our device, and we're just going to use the CPU for this, but if you do want to do anything seriously, you will want to use your GPU. But that's a lot harder to set up because you need to install CUDA and a few other things to make sure that works correctly. And we're just going to move the model to the device. And then we're just going to have that. We're actually going to include this in a while loop so we can run this many times. We're going to have our input data, which we're just going to get from the user, so ask the AI. Then we're going to get our tokens from our tokenizer, so this turns this input data that we as a human understand into something that the language model understands. And then we're going to need to do another operation on them here, which I think load them in and all that. And then we need to get our output from the model, so and then we put our tokens in. We're going to tell it the max new tokens it's allowed, and we're just going to set that to 128. Models like this generally can't have too many. And then we're going to decode what it turns into something that we can understand. And we don't actually need the special tokens because those aren't something we can understand. And then we're going to for loop through the text and print it all out. So this should work, and the model has loaded, and we're just going to ask it just hello, and I seem to have made a typo somewhere. There we go. It's a very simple mistake. I'm just going to ask it hello. And I've made another simple mistake there. This is why we use a proper IDE. I just haven't set up one on this computer. Again, why we set up a proper IDE. And it's returned something, it's not well trained, so it's not going to be anything that's particularly useful. It's just some basic contents of its training data. For training, we're going to need a lot more imports. So I've just written these out already. I didn't explicitly tell you to import pandas, but I believe that pandas is included in one of the other imports when you download it. If it's not, just download pandas as well. So first thing we're going to have to do is we're going to have to read in our data. I'm just using a really simple CSV, which is actually a text document. And then we're going to have to make our data set. So that should be very easy. Then we're going to have to get our tokenizer. Same as last time, same place. And then we're going to define a tokenize function. So we're going to use this a little bit. So that I keep trying to define keywords. I'm used to usually programming in other languages, but those are not keywords. Sorry, tokenized data equals, we're going to have to map this. Then we have to create a data collector. And assign the tokenizer. Then we're going to have to load the model like we did before. Just on here. And then we should assign the pad token. This is just something that needs to be done to ensure it does work correctly. And then we need to resize, so we need to resize. And then we need to assign the training args, so targs, I'll just call them. And so we're going to set our output directory, and that's just going to be results, yeah. And then the evaluation strategy would be epoch, and then learning rate equals 3 times 10 to the minus 5. Now that is a good rate. I found that anything substantially higher than that is going to run into problems with things being learned way too quickly, and if you give it some text it will just latch onto that and can kind of overuse it, essentially overtraining. These batch size are sort of also something you would want to keep this size if you are dealing with a GPU with a limited VRAM. So we're just going to set 3 epochs and some weight decay. And we're also going to set the train up as well. And we're just going to set the model. DArgs equal TArgs. The data set equal to, hang on, what did I call that? Tokenized data. And we're actually going to use the same evaluation data set. Though if you wanted to set this up very well, you might want to use different ones. And the collator is going to be, and the tokenizer is just going to be, again, just the tokenizer. I almost certainly made a spelling mistake somewhere along here. We train, we get results by evaluate. By evaluating, we print the results. I think it actually prints a lot more than just this, so it'll keep you company while it's running. Not that this one runs particularly long, and we will save the pre-trained, and we'll save it so we can edit it again. If you want to train this, you will need to load it from that fine-tuned training place. Now for data, you're going to want to kind of just write some stuff. I'm using, first thing I thought of was just Skyrim. I don't know why. I'm just going to input a load of stuff about that, some really random, useless stuff. And what you want to use is you want to start with text, then you want to have lines, and each one start with and end with a quotation marks. So we'll just create one here. I don't know, white run is in Skyrim, and Skyrim has a hold called white run. Technically you generally want longer training pieces of data than this, but this is fine for my use case of just demonstrating. So after fixing a few small errors, you can just see what I had to fix. It's just spelling mistakes, so nothing major. Just like didn't include 4 in the name of the import. That's trained, and you can see it does output a lot of just a lot of stuff to make sure you know it's working correctly. And so now we can go and test it. For this bit of code, we're now going to have to repurpose it to read from the fine-tuned model. So we're just going to change where it loads the model from, and we're going to run that, and we're going to see what it gets. So we're asking the AI, and it's still not going to be very good. It's still going to not understand what it's talking about. But as we can see, it sort of includes some of the stuff it's learned. You can sort of see that what it's learned already. But it's still very, very it's not very smart. You can see definitely is spitting stuff back. So you'd have to train an awful lot more for it to be able to properly kind of be useful and be able to talk to it.